Hello, welcome. Today we are going to review Unit 8, Polynomials. This is the unit we were working on right before school closures back in March. So I just wanted to go through some review of what you learned back then because I know it's been a little while. So the first objective we went through was Objective 1, Identifying and Classifying Polynomials. For this objective, we're just naming polynomials by degree and number of terms. If you look back at your notes, we had a chart that told you all the names for degrees and for terms. We're going to review some of those today. Now, in order to classify something, it must be in standard form. That means the highest exponent should be first, and then they should go in order to the lowest exponent. So from highest to lowest. Number 1 is in that form. So now when you're looking at degree, you're looking at the highest exponent. The highest exponent in number 1 is 4. So the name of a degree 4 is called a quartic. When we're looking at number of terms, we're simply counting how many terms do we have. We have 1, 2, 3, 4 terms. So something with 4 terms is called a polynomial. That's because any polynomial with degree high or with number of terms higher than 4 is just called a polynomial. There's no special name for anything over 4. For the second one, it's in standard form because there's only one number. There are no variables, so therefore there is no exponent. The degree would then be 0. The name for that was constant. For number of terms, there's only one term, just that 7. So that is called a monomial. Okay, for number 3, the highest exponent is 2. We called that a quadratic. There are 1, 2, 3 terms, so we call that a trinomial. For number 4, the highest degree is 5, because there's only one degree, and the highest one is 5, and that's called a quintic. For number of terms, there's only one term, so we call that, again, monomial. Okay, and for number 5, the last one in this section, the highest exponent is just an x. That means if there is no exponent on the x, it's understood to be a 1. A 1 degree is the highest is called a linear. And the number of terms, there are 1, 2, so that is called a binomial. So that is all for Objective 1, identifying and classifying polynomials. It's pretty straightforward. The only thing you may need to do is go back and review the chart that you got in class that just listed all of those names. Okay, so we are now going to move on to Objective 2, which is to write a polynomial given the solutions. Now, we can write polynomials in 2 ways. We can write them as factored form, which is just listing out all the factors, or standard form, which again is highest exponent to lowest exponent. In order to get standard form, you must first find the factored form and then multiply it together to get it into the standard form. I'm actually going to skip down to number 13, and then we're going to move back up to 11 and 12, because factored form is a little bit less work. So we want to write in number 13, a polynomial in factored form with integral coefficients. That means there are no fractions or decimal coefficients, only whole numbers. And they have the following solutions: 3/4, -1/5 with a multiplicity of 2, and 7 with a multiplicity of 3. Now, 3/4 is a fraction, but we need integral coefficients. In order to get that, you must think what factor, if I set it equal to 0 and then solve, would give the solution 3/4. That answer is actually 4x minus 3. Let's think about why that would be. If I were to set 4x minus 3 equal to 0 and solve it, I would add 3, so it'd be positive, and then I would divide by 4. Well, 3/4 would be my solution. So the easiest way to put it in the factor with integral coefficients is to take the denominator and put that in front of your x, and then the numerator is what you're adding or subtracting. I know I'm subtracting 3 because it's always, the factor is always the opposite sign of its solution. So taking that same idea and looking at -1/5, I said to make the denominator the coefficient of your x. So that means I'm going to have 5x. Because my solution is negative, that means I must be adding to get my factor. So 5x plus the numerator, which is 1. Let's think about that before we move on. 5x plus 1, if I set that equal to 0, to solve for x, I would subtract 1. So I would have -1. And then I would divide by 5. -1 divided by 5 is -1/5. So that does work. Now we have to think about multiplicity. We've got multiplicity of 2. That means the exponent is 2. Now, I can't type exponents on this, so what I'm going to do is type a caret, but you know that means the exponent is 2. So far I have 4x minus 3, that came from the solution 3/4. Then I have 5x plus 1 squared, because it is a multiplicity of 2. My last factor is 7. There is no denominator. That means x is just alone with a coefficient of 1. 7 is positive, so the solution is positive. That means my factor is negative. So it's x minus 7. Double check that. If I were to set x minus 7 equal to 0, I would solve it by adding 7. That would give me a positive 7, so therefore that is correct. Multiplicity 3 means that that factor occurs 3 times, so it has an exponent of 3. So again, my caret, 3. So that is your solution to writing the polynomial in factored form with integral coefficients. So therefore, my solution is 4x minus 3 times 5x plus 1 with an exponent of 2 and x minus 7 with an exponent of 3. That is the factored form of that polynomial. Okay, so for number 14, we are writing a polynomial in factored form again. It has the following solutions: 1/4 with a multiplicity of 5 and 7 with a multiplicity of 4. So 1/4 is a fraction again, so we talked about the denominator is the coefficient of x for your factor. So I have 4x. It's going to be minus 1 because my solution is positive. Therefore, my factor is negative, and the numerator is 1. So 4x minus 1. If I were to set 4x minus 1 equal to 0 and solve it, I would add 1 and divide by 4, which would give me a positive 1/4. Multiplicity 5 means that factor occurs 5 times. So therefore, it has an exponent of 5. The next solution is 7. It's a positive 7. It's a whole number, so x is by itself. It's just an x with a coefficient of 1. 7 is positive, so therefore the factor is minus 7. If I were to set x minus 7 equal to 0 and solve it, I would add 7, and that would give me that x is positive 7. It has a multiplicity of 4. That means x minus 7 occurs 4 times. That means my exponent would then be 4. So my solution of a polynomial in factored form that has the solutions 1/4 multiplicity 5, and 7 multiplicity 4 would be 4x minus 1 to the 5th power and x minus 7 to the 4th power. So now looking at objective 2, number 11, we want to write our polynomial in standard form with integral coefficients not in factored form that has these following solutions. To do that, we must write it in factored form first. Factored form is what we were just working on. So if I have 1 as a solution, my factor would be x minus 1, because remember factors are the opposite sign. 0 as a solution is a little tricky. All that means is your factor is just the variable x. Usually we want to put that factor in the front of our factored form, so I'm just going to write it up front. Then the factor 1, or the solution 1/3 is one of those fraction ones. So that means the denominator is 3. That's the coefficient of x. It's positive, so that means my factor is negative 1. 3x minus 1. The last factor is negative 3. Because it's negative, my factor is positive, so it's x plus 3. That's the factored form. In order to get it into the standard form, you must multiply all 4 of those factors together. I suggest multiply the first 2 together, multiply the last 2 together, and then multiply those 2 solutions together. So the first 2 solutions, 2 factors are x times x minus 1. When I multiply those together, I end up with x to the 2nd power minus x. And the second solution, the second 2 factors are 3x minus 1 and x plus 3. When I multiply those together, I end up with 3x to the 2nd power plus 8x minus 3. Now you can multiply those 2 factors by using FOIL, or you can use the box method, whatever works best for you. Once you have those 2 multiplied, now you have to multiply them together. When you do that, you can again use FOIL or the box method, whatever you need to. But when you do, your final answer should be 3x to the 4th power plus 5x to the 3rd power minus 11x squared plus 3x. All right, number 12 is much the same way. So first you write out your factored form. For the factor negative 3/4, the solution negative 3/4, the factor would be 4x plus 3. For the solution 3, your factor would be x minus 3. Because it's multiplicity 2, that would be raised to the 2nd power. Writing that out fully, you have 4x plus 3 times x minus 3 times x minus 3 again. That's because you are just writing x minus 3 twice. That's what multiplicity 2 means. It means that factor occurs twice. Then what you would want to do is multiply all 3 of those together. I would suggest multiplying x minus 3 times x minus 3 first, and then multiplying that answer with 4x plus 3. So I'm going to rewrite 4x plus 3. When I multiply x minus 3 times x minus 3, I get x to the 2nd power minus 6x plus 9. Again, you can do that with FOIL or with the box method, whatever works for you. Your final step would be to multiply 4x plus 3 times x squared minus 6x plus 9, using box or whatever method works for you. When you multiply that all together, you should end up with 4x to the 3rd power minus 21x squared plus 18x plus 27. So that is all for the second objective, which is writing your polynomials based on the solutions, whether that be in factored or standard form. You just need to pay attention to which form they're looking for. In factored form, just leave the factors. Don't try to multiply them all out. Standard form, you do have to go through and multiply them out.